Welcome back to the explainer. Have you ever woken up from a dream that made perfect, absolute sense in your head, but the second you actually try to explain it to someone over breakfast, it sounds completely absurd? You find yourself saying something like, well, I was in my childhood home, but it was also a spaceship, and my boss was there, but for some reason he was a golden retriever. Today, we're unpacking a fascinating clinical case study grounded in the brain kinematics model and continuity theory that investigates exactly this phenomenon. We're going to decode the fragmented mind and discover why your most disjointed dreams might actually be a literal masterclass in cognitive organization. To really understand this, we need to look at a highly specific, totally fragmented dream from our source study. Just listen to this exact sequence of events reported by the dreamer. First, quote, there was a machine assembly of gears. Then, abruptly, the scenario changed to, my smallest brother was waiting with his small baggage behind the door. Then, another totally abrupt shift was with a competitive past colleague, now friendly with me. And finally, another sudden change. Thought could be a mouse, but face of goose appeared from behind furniture. It's incredibly jarring, right? 4 completely isolated, unconnected scenes, just jumping from one right to the next. Okay, let's dive into this, because here is the core mystery our researchers faced. The dreamer remembered the exact order of these events perfectly. The timeline was completely solid, but there was absolutely zero story connecting them. The gears didn't cause the brother to appear, and the colleague obviously had nothing to do with the goose. So we have to ask, can a dream possess strong temporal organization without possessing strong narrative organization? Like, is it actually possible for your brain to be highly organized chronologically, even when the story itself is just a complete broken mess? Section 1. Deconstructing the clues. 4 memory packages. So rather than trying to tell one continuous story, the Brain Kinematics Model, or BKM, suggests that the sleeping brain sequentially samples different, entirely independent memory packages. It's kind of like your brain is just clicking through totally different folders on a hard drive. You've got one folder for engineering knowledge, one for family, one for your professional life, and one for environmental vigilance. Our first clue begins with those scattered mechanical gears. Now, the natural instinct is to think, oh, it's just a broken machine. But the researchers point out that these gears are actually distributed components, searching for an arrangement. Symbolically, this represents cognitive elements literally waiting to become a higher-order continuum. So this isn't about emotional processing at all. This is pure structural cognition. Your brain is visualizing the very concept of organization, taking separate pieces and trying to figure out how they might eventually fit together. Moving to the second scene, we see the dreamer's youngest brother. Notice the really specific details here. He has small baggage, and he's waiting patiently for the sunrise so he doesn't disturb the dreamer. Now, this isn't a scene of active conflict. The sunrise actually represents the transition from unconscious processing toward conscious cognition. The brother waiting quietly reflects a deferred integration of interpersonal memories. It's like the brain is essentially saying, hey, we have some differing viewpoints here, but we're just going to respectfully postpone this interaction until we are fully awake. The third scenario shifts to the professional realm, and man, it perfectly captures emotional memory reconsolidation. We have a colleague who, in the past, was competitive, oppositional, and pretty prideful. But in the present dream state, they're friendly, cooperative, and just chatting about how fast technology has changed. What's happening here is the brain is actively updating this memory file. It's taking the old emotional focus of interpersonal rivalry and replacing it with a sense of shared historical continuity. The conflict is gone. The shared passage of time is what really matters now. Finally, we reach the fourth clue, which represents a fascinating predictive processing error. The dreamer hears a noise and expects a mouse, a small, hidden, uncertain threat. But instead, a goose appears, and a goose is large, loud, territorial, and absolutely impossible to miss. By swapping the expected hidden threat for an undeniable, obvious reality, the brain is actively updating its internal models. It's replacing an anxious expectation with a definitive, highly visible presence. Section 2. The aha moment, reorganization. And this brilliantly illustrates the massive gap between the surface weirdness of a dream and the profound underlying cognitive task actually happening in the sleeper's mind. On the surface, sure, it's just gears, a brother, a coworker, and a bird. But structurally, the brain is performing some heavy lifting reorganization across 4 completely different domains of the dreamer's life. Despite the total lack of narrative connection between the scenes, every single episode systematically transforms an old, fragmented state into a calmer, newly reorganized state. Think about it. Scattered gears become a potential machine. Different familial viewpoints become peaceful coexistence. A professional rivalry transforms into historical friendship.
and a hidden mouse becomes a visible goose. The underlying organizational theme here is just stunningly consistent. The brain is resolving tension and creating structure at every single step, even without a coherent story.
Section 3, the grand theory, 2 types of continuity. Now, what's really interesting about this is how this specific detective work actually elevates into a grand theoretical framework for how the brain structures memory. It shows us that continuity in the brain exists in 2 distinct forms. The first is sequential continuity. This is what our bizarre case study had in absolute spades. It's the preservation of chronological order. The dreamer remembers scene A, then scene B, then scene C, then scene D perfectly. The sequence is totally locked in. However, one event does not cause the next. The gears don't cause the brother doesn't cause the colleague. It's just a perfectly ordered list of entirely independent events. The second form is dynamic continuity. Now, this is the classic, epic, movie-like dream you sometimes have, where scene A actively transforms into scene B, which directly causes scene C. It's a causal, evolving storyline. Our fragmented case study exhibited incredibly weak dynamic continuity. And understanding the difference between these 2 definitions gives us the exact key to decoding how the brain structures memory every single night. We can actually map this out mathematically. On one axis, we have sequential continuity, or Cs. On the other, we have dynamic continuity, or CD. If you have high Cs and high CD, you get those long, flowing narrative dreams. If you have low Cs and low CD, you wake up with a highly disorganized, confusing mess of images. But look at the top right. High Cs and low CD. That is our exact case study. Ordered, but fragmented. It proves that these 2 variables operate totally independently in your brain, giving us a completely new way to categorize and analyze the dreams we have. Section 4, reconstructing the night mixed sleep stages. So conceptually, we understand the math here, but how does the physical, biological brain actually stitch these entirely independent memory packages together? Do they all happen at once? Or is the brain pulling a fast one on us when we wake up? Well, the Brain Kinematics Model proposes that these memory packets might not have happened one right after the other at all. For example, the abstract imagery of the scattered gears might have originated in the lighter N2 sleep stage early in the night. Then the family memory of the brother might have triggered during the first REM cycle, the professional memory during the second REM cycle, and finally, the goose in the final REM cycle right before morning. It's only at point number 5, awakening, that the working memory grabs these totally independent files and actually reconstructs them into a single chronological sequence. So the crucial point is that recalling a dream isn't like hitting play on a video recorder. The implications here for the brain kinematics model are absolutely profound. First, memory packets can remain completely independent. Second, the act of awakening is an active process that reconstructs, rather than just retrieves, your experiences. And third, your waking recall preserves the order in which these memory hubs were activated over the course of the whole night, threading them together retrospectively into one conscious string. Your waking brain is literally acting as an active storyteller for independent files. Which leaves us with a totally paradigm-shifting thought. The next time you wake up and try to explain a dream that jumps from your kitchen to your high school to a random submarine, don't just dismiss it as a random broken mess. Is it just noise? Or is your waking mind actively reconstructing a highly organized, hidden continuum of structural memory, emotional reconsolidation, and predictive updating? The fragmented mind, it turns out, isn't broken at all. It's just speaking in the brilliant, complex language of pure organization.